on problem three, we're given the graph of f of x, and we're asked to find out of a selection of graphs what the graph of capital F of x will look like, the antiderivative should look like. The primary thing we want to notice about the graph that we're given is that the graph of the derivative is never negative. So since little f of x is never negative, capital F of x is never decreasing. In the particular selection of graphs that we have available to us, there's only one choice that fits that bill. So this leaves us with one choice. So they might have rearranged them, but figure number 2 is the only choice. We know we should see a graph that is always increasing. If we're going to draw it, we know we have to draw a graph that's always increasing. At x1, x2, and x3, or sorry, at x1 and x3, we should see the graph of capital F flatten out because the derivative is 0. And at x2, since the derivative is changing direction, we'll see an inflection point in the graph of capital F. So at least from x1 to x3, we should see the graph be flat at x1 and also flat at x3. The graph should always be increasing. It should be concave up before x2 because the derivative is increasing, and concave down after. So we should observe, since little f is 0 at x1 and x3, so f at x1 and f at x3 are both equal to 0, so capital F is flat at x1 and x3. So flat at those points. Little f is increasing from x1 to x2, so we should draw the graph concave up. And then similarly, little f is decreasing, little f increasing. And then from x2 to x3, little f is decreasing. So capital F will be concave down. So this is an exaggerated version of what we should be seeing. This was a multiple choice question, so we only had, then there was only one of our choices had capital F always be increasing. So that made that part easy, but there's other things that we should look at before we make that decision. Any questions? All right, let's see if I can actually pause the video here and do some more problems.